fundamental material properties. Okay, and we can actually measure the strain, okay, on a real piece, and then come back and say, well, that stress then is such and such because I know what the E is. Steel has an E. Aluminum has one, but it's about 1/3 of that of the steel. It's interesting to also note it has about 1/3 the density. Glass is a lot different. You know, fact is, glass doesn't bend over like what I just showed you there. It does different things. So there's some babbling going on down here about the same thing. So we know that sigma equals P over A, right? And we know sigma is equal to E epsilon. So there's different combinations then of formulas you can have, because you can have P is equal to, well, A E epsilon. Or whatever you want. You can have epsilon then is equal to P over AE. Whichever direction you want to go. It's all kinds of things, right? And that's all the formulas we got right now. That's it. A little bit more, though, is here's how stress strain curves can happen. This one happens to be percent because the strains were huge. Okay, huge. I took some rigid polyester and some what's called flexible polyester, and I ran the test on the rigid, which is this one like here, and that's like glass. The X means it broke. You know, it's absolutely straight and broke. The flexible is this little line right down here at the bottom. It has a very, very low E. And it broke. Okay. Then I took 20% of the flexible resin, mixed it in with 80% rigid, and tested it. And I got that green curve. And I just kept changing the values. And I was looking for one that looked like, basically one that looked like that. Even any of these would have worked in here where it's pretty flat out here. I wanted it basically come up and be flat, which this one does. Okay. Well, you know, you get the E for this one, and then you come in here and go, well, the last point on that, where it's proportional, that would be my proportional limit. And you see here, you go like that. The E is a lot less. My proportional limit's a lot less. So there's all kinds of things going on. Here is a strength. Ultimate strength. That's the highest stress that you can have before it breaks. So here, that would be here, right? So it's the highest stress you can get to without it breaking. All right. Well, the proportional limit is not exactly the best thing in the world to be using. So I've got about 3 minutes, and I got about 10 minutes worth of stuff. And I know I have at least one student's got to go to another class here. So if you look in your book, you'll see some curves that are for like what's called mild steel, which is structural steel, like your regular I-beams are made out of. And we have strain down here, and we have stress here. And this comes up, it's pretty straight, and it has a little blip here. And then it's fairly constant here. And way out here it starts building, and then it'll break. Okay. And what's happening here, why it goes down, is that it starts to neck down, so it has smaller cross-sectional area. If you divide it by the real cross-sectional area, you'd have a higher stress. It wouldn't go down. Okay. But right there, that is sigma ultimate. That stress right there. You absolutely never want to go past that, right? And this one here is, because it flattens out, is sigma yield. Is that familiar, John? Sorta? Okay, but this is steel. Aluminum, which is more like the curves that we looked at before, are straight and then they kind of round off and do something like that. Okay, we don't have a flat spot up here, right? Where we'd say, well, that's good enough. We'll just keep it below that and it's close enough to wherever that point is and call it good. So we got our E here, that's no problem. What we do is we come over here and we have what's called an offset. So this is the offset strain. We just take a line parallel to the straight line portion. Come over a specified distance here, and then that is my, we'll still call it yield point or yield strength. Okay? And we use interchangeably the yield strength, yield point, and the proportional limit. We just sort of glump those all together. So in the back of your book, back inside cover and the front side cover, you'll see tables of materials, and in there we'll have Young's modulus, E. Okay, and it will have element strength. It will have most cases for that, and it'll also have the yield strength. That'll just be in one column. Okay, and that's what we use. We want to stay in this region, and so what you're going to be doing is you're going to be taking raw data and you're going to be plotting that data. It's a good time to learn how. If you don't know how to do it now, learn how to use Excel. Is that how you spell Excel? There's a C in there somewhere? Huh? Is that right? It didn't look right for me. IR engineer, and I spell real good. Anyway, it's a good time to start learning how to do some of this stuff and get good at it. Okay, see you next time.